This is an instructional video on how to complete two-step equations that either involve parentheses or they involve a binomial divided by a monomial. So my first one that I'll do is an example that involves parentheses. So I have 100 equals 10 multiplied by x plus 3 in parentheses. So there's a couple ways to do this. I'll do both ways and you can pick whichever one you're most comfortable with. But I find that one is a little bit more efficient than the other. So the first way I'll do is not my preferred method, but you might enjoy it. So the first way is to expand the right side of my equation here by using the distributive property. And we know the distributive property means you take this 10 and you distribute it, or you multiply it by both of the terms inside of the brackets. So we have a 10 times an x gives us a 10x, and then a 10 times a 3 gives us a positive 30. So now we have two separate terms that we can deal with separately. So the first thing I would deal with here in trying to isolate my x is this plus 30. So I want to get rid of my plus 30. I'm going to do the inverse operation, so I'm going to subtract 30. Okay, so 100 subtract 30 gives me 70. And on this side, my 30s cancel out to 0, so I end up with 10x plus 0. But we don't need to write the plus 0. So now I just need to get rid of the 10 in front of the x. So that is a 10 multiplied by x because that's a coefficient. So if we have a 10 multiplied by x, we need to divide by 10 in order to get rid of it. So 10 over 10 just equals 1x. And we need to divide by 10 on this side as well. So 70 divided by 10 is 7. So I get an answer of 7 equals x, or x equals 7. I can check my answer by writing out my original equation and substituting my answer of 7 into my equation where the x is. So 100 equals 10. Instead of an x, I'll write a 7. And I'll see if these two sides of the equation equal out. I'll do my brackets first because that's order of operations. 7 plus 3 is 10. And now I can multiply my 10 times 10, which is 100. So that equation does work. So x equals 7 is the correct answer. So I'm going to do that exact same question, but I'm going to do it a different way this time. And you might find that you actually prefer this way. It's a little bit more efficient, I find. The same question, 10 multiplied onto x plus 3. So what I'm going to do instead, since this 10 is being multiplied by everything inside the brackets here, I can do the inverse operation of multiplying by 10, and I can just divide the whole thing by 10 to get rid of it right from the start. So I must also divide by 10 on my other side. 100 divided by 10 is 10. And on this side, I'm just left with x plus 3. So now it's quite easy from here. All I need to do is get rid of that plus 3 by doing the inverse, subtracting 3 from both sides. So 10 minus 3 is 7, and the 3's cancel out, leaving me just with x. So you see I get the same answer, but it's a little bit more straightforward, I find. Just to divide right from the beginning, divide the whole thing by this number that's outside of the brackets. Okay, now I'll do an example where we have a binomial divided by a monomial. So I have x plus 3 all divided by negative 6 equals 5. So what I'm going to do here is the first thing I need to deal with is anything that's on the denominator. I need to get rid of that denominator, and then I can deal with what's on the numerator. So how do I get rid of a divide negative 6? I have to do the inverse, and I multiply by negative 6. And of course I need to do that on both sides. So on this side, my negative 6's cancel out, leaving me just with x plus 3. And on my right side, I have 5 times a negative 6, which gives me a negative 30. Now I just need to deal with this plus 3. And so in order to get rid of a plus 3, I subtract 3, because that's the inverse. It means I also subtract 3 on this side. So these cancel out. I'm left with x equals negative 30 subtract 3. If I have a negative 30 and I'm subtracting 3, you could think of it as adding the opposite. So now I have negative 33. And that's my answer. I can check my answer by substituting negative 33 back into my original equation. So instead of an x, I'm going to say a negative 33 plus 3 over negative 6 equals 5. I'll work out my numerator first. Negative 33 plus 3 is a negative 30. Divide by negative 6 equals 5. Everything else stays the same. Then I have a negative 30 divided by a negative 6. We know a negative divided by a negative is a positive 5. In this case, equals 5. So I know my answer is correct. X equals negative 33 because when I put it into this equation, the left and right side balance out. Okay, so that's an example of how to do both equations using parentheses and equations that involve a binomial divided by a monomial, making sure that you always take care of that denominator first before you tackle anything in the numerator.